Hi everyone, this is Practice Summative, paper 2, question number 5. So in this question, the diagram shows two regions labeled as A and B. And region A is bounded by the curve y equals to x over a cubed. I label it as y1. And x equals to a and the x-axis. Whereas region B is bounded by the curve y equals to a over x to the power of 3. Let me label this as y2. Okay. X equals to A, X equals to B, and the x-axis. So this is region B. So we need to find the area of region A in terms of A. So we just integrate. So to find the area of A, all right, the area under the curve, we just need to integrate from the boundary. Lower boundary is 0, upper boundary is A with respect to X. So the function of the curve is X cubed over a cube. So let's just integrate this. We increase the power by 1 and reduce by the new power. Copy the rest. And then the boundaries from 0 to a. Substitute the a in. So we have a to the power of 4 over 4a to the power of 3 minus, substitute the 0, we have 0. So therefore we will get of a, we apply the law of indices. So 4 minus 3, we left with 1. So a over 4 square units. So we found the area of A right away. Next, we have to find the area of region B in terms of A and B. So for part B, so we got to integrate from A to B, okay, with respect to X, of the second function, y2. So we have a to the power of 3, and I write in the negative index, so x to the power of negative 3, so that we are able to integrate these terms. So we will then have a cube, x to the power of, increase the power by 1, divided by the new power. Okay, integrate from a to b. Let's write properly. First, we have negative a cubed over 2x squared. Then only we substitute the boundary value in. So we have negative a cubed over 2b squared minus the negative a cubed over 2a squared. Let's simplify the a cubed and the a squared. So we left with negative a to the power of 3 over 2b squared plus a over 2. Okay, let's find the lowest common multiple. So the lowest common multiple is 2b squared. So let's multiply b squared in both numerator and denominator. And the common denominator 2b squared, we have ab squared minus a cubed. Therefore, the area of B is given by this. Okay, ab squared minus a cubed over 2b squared. Next, we have to show that the region, the area of A, we have to prove that area of A greater than half area of B. Okay, how do we prove this? Yeah, okay, part C, let's write down area of the region A, which is A over 4. And then the area of the region B, okay, area of region B is AB squared minus A squared over 2B squared. Okay, so how are we going to put the area of A and area of B together? So let's separate this one, A over 2. And then over here, we can split this into 2 fractions. Okay, so over here, to get A over 4, I just need to times with 2. Yep. All right, 2 times A over 4, we get back A over 2. Whereas inside the bracket, we simplify, we have 1 minus A squared over B squared. So isn't it A over 4 is the area of region A? So 2 times of area of region A. And then over here, 1 minus A squared over B squared. Okay, so over here, we are given that A is in between 0 and B. Therefore, we know that 1 minus A squared over B squared will be less than 1. Okay, definitely less than 1. And then we multiply 2A to the power of A on both sides. So 1 minus A squared over B squared, that is less than 2 area of A. And isn't it this one is actually area of B? So area of B is less than 2 area of A. And let's make area of A the subject. So area of B over 2 is less than area of A. So we have just proven that area of A is greater than half area of B. So we have just shown. Okay, so we found the answer for question number 5.